Today our topic is exploring solids. Our learning target, how can I identify solids? Polyhedron is a solid that is bounded by polygons. And it's polyhedra for plural, or you can call them polyhedrons. But you might see polyhedra. So know that that's plural for polyhedron. And then a solid is a three-dimensional figure. Like cubes are a normal three-dimensional figure that we think of, like dice and things like that. Faces are the polygons that make up the outside of a polyhedron. So if we look just down here at this example right here we have rectangles that are making up the faces of this polyhedron. So those would be the faces. Then an edge is a line segment formed by the intersection of two faces. So wherever those faces are meeting, there's an edge. And then a vertex is the point where three or more edges meet. So there are one vertex, two vertex, and see all the vertices. To name a prism, you name prisms and pyramids by the shape of their bases. So prisms have two bases and pyramids have one base. And then if it's a regular polyhedron, all the faces are congruent regular polygons. So if we look down here, we have two kind of categories, polyhedra and not polyhedra. So our two main categories of polyhedra are prisms and pyramids. Pyramids come together at a top point, and then prisms are more like a box shape. Not polyhedra are cylinders, cones, and spheres, because our definition, if we look back up here, is a solid that's bounded by polygons. So if we look at a cylinder, a circle is not considered a polygon because it doesn't have edges and vertices. Okay, and so cones, they also have that circular shape, and spheres have that circular shape as well. So anything that has that circular shape is not going to be a polyhedra. But things that are made up of polygons, like prisms and pyramids, those are polyhedra. To talk a little bit more about those regular polyhedra, there are 5 regular polyhedra. They're called Platonic solids after the Greek philosopher Plato. The 5 Platonic solids are shown. We have a regular tetrahedron, which has 4 faces of congruent triangles. A cube, 6 faces of squares. A regular octahedron, so it's got 8 sides, and that's made up of 8 regular triangles. A regular dodecahedron, so it's got 12 faces, but these are made up of pentagons actually. And then a regular icosahedron, so the icosahedron is made up of 20 congruent triangles. So those are the 5 different ones that are actually regular polyhedra. All right, so if you go to the back of your paper, we got some examples to kind of practice naming polyhedra. So tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. Well, let's just start with, is it a polyhedron? For A, yes, it is, because it's made up of all polygons. We've got all these rectangular shapes. So this would be some sort of prism. Letter B, yes, this is a polyhedra because it's made up of all polygons, and it's going to be a pyramid. And then C is no, because it has that circular shape. This is a cone, which is not a polyhedron. So if we look at letter A and B, we want to name the polyhedron. So let's go to that piece. This we know is some sort of prism, but we need to name it by its bases. So these 2 sides are the bases. And those are rectangles because we have the 90-degree and the 2 pairs of opposite sides that are congruent. So this would be a rectangular prism. And then for letter B, pyramids have 1 base, and the base is that bottom figure underneath the point. So if we look, this has 1, 2, 3, 4, 5, 6 sides. So this would be a hexagonal pyramid. Then the last piece is we want to find the number of faces, vertices, and edges. So we can abbreviate that: faces, vertices, edges. Faces for this prism is going to be the two bases and then the four pieces that make up the other sides. So we're going to have 6 faces. Vertices, we have 1, 2, 3, 4, 5, 6, 7, 8 vertices. And then for edges, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. For that shape, it was pretty easy to count the faces, vertices, and edges. However, for our hexagonal pyramid, it's going to be a little bit more difficult. The faces and the edges the faces and the vertices we should be able to get, but the edges can be a little difficult because if we can't see them all, it's a little hard to count. So that's where we come into this theorem called Euler's theorem, or Euler's theorem, I think is how you properly pronounce his name, but I like to say Euler's. But his name is properly pronounced Euler's. The number of faces, vertices, and edges of a polyhedron are related by the formula F plus V equals E plus 2. So if we just look right here at our faces and vertices, if we put 6 plus 8 for our faces plus our vertices equals 12 plus 2, does that hold true? Yes, because 14 does equal 14. So we can use this equation to help us find one of the pieces if we're having trouble counting. So if we know our faces, we have one face for our base, and then we're going to have 6 triangles, one for each side of that hexagon. So we're going to have 7 faces. Edges, we have one edge here, 2, 3, 4, 5, 6, 7, not 7 edges, 7 vertices, my apologies, talking vertices. And then we can use this to help us know the number of edges that we have, because our faces plus our vertices is going to equal our edges plus 2. So we have 7 plus 7 equals E plus 2. 7 plus 7 is 14 equals E plus 2. Subtract 2 on both sides, E equals 12. So we do have 12 edges to this hexagonal pyramid. Again, using Euler's theorem, we have find the number of faces, vertices, and edges of the regular octahedron. Check your answers using Euler's theorem. So if we have an octahedron, regular octahedron, that means there are 8 triangles. So we're going to have 8 faces. Get those vertices. We have 1, 2, 3, 4, 5, 6 vertices. Edges, if we want to take a guess or try, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which should work because faces plus vertices equals edges plus 2. Faces plus vertices equals edges plus 2. 14 equals 14. We are good to go. Last one piece is a cross section. So a cross section is the intersection of a plane and a solid. So a solid, remember, is that 3D figure, and a plane is a 2-dimensional figure. So when a 2-dimensional figure crosses a 3-dimensional figure, it makes a cross section. So here, this 2-dimensional plane crossed a 3-dimensional pyramid, and the cross section made the shape of a triangle. So if we look in our examples, describe the shape formed by the intersection of the plane and the cube. So our cube is our 3-dimensional. Our plane is our 2-dimensional, and we want to know what that shape is making. So if we have a cube, we know that it's a square. So when this plane crosses, this purple section is actually going to be a square. Here, this plane crosses it diagonally, so we have the shape of a rectangle. And lastly, if we look here, this kind of crosses it diagonally, and it looks like we have a trapezoid. Alright, so that's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.